Okay, we're going to go on to 8 plus 8.2 here, and we're going to be graphing much more complicated rational functions. We're just going to introduce them with the concept that this guy right here still tells us where asymptotes is. So this is kind of written in the standard format, right? We got our A is 1, B is 1, but we got H and K here. And H and K used to be able to tell us our, in fact, this one sure does, tells us where our asymptotes do. It's 2 right and 3 up. And there's an asymptote right there and there. Let's talk about this asymptote. This asymptote, right, which is x equals 2, defines our domain. Our domain is not allowed to be 2. In fact, I'm going to write this in set notation in a way that we usually write set notation based on what our domain is. We're going to write set notation this time based on what our domain isn't. So I'm just going to say, hey, x is everything but 2, x isn't 2. Just like that. So the domain of this function would, based on this vertical asymptote, would be x isn't 2, which is what we practiced the last time I saw you guys. And this is because the function isn't defined at x equals 2, meaning that if I plug 2 in there, 1 over 2 minus 2, or 1 over 0, right? 1 over 0 is undefined. And when you're undefined, it doesn't make sense, you can't graph it. The graph has a vertical asymptote at x equals 2, all right, because of this. And this graph does something. If you did graph this, right, and I'm going to show you how to write something in a new way. As x approaches 2 from the positive side, and let's do a little graph so you can show you what it would look like, right? Right at 2, and let's go ahead and put our other. So I'm gonna go ahead and draw this vertical asymptote and the horizontal asymptote. And as x approaches 2 from the positive side, my output approaches infinity. All right, so that means as I come in from the positive side, it shoots up, which is what you're used to. And let's write this as x approaches 2 from the negative. I just realized I wrote a 2 here. This should say a positive side right there. And as x approaches 2 from the negative side, just another notation that you can use, the output approaches negative infinity, which means on this side it goes down like that. All right, so as I'm coming from the positive side, I go up. As I'm coming to 2 from the negative side, I go down. All right. This leaves us a little more to explore, and we're just going to kind of show you this for a little bit. We're going to assume that we probably have an asymptote here. This says possible, so there's a hidden trick in here, right? There's something that happens later on, but we have a possible asymptote here whenever my denominator would equal 0. So it looks like at 1, I'd have a possible asymptote. This guy right here, if I set that equal to 0, right, that would be an asymptote at negative 1. So we're graphing all the roots of the denominator. That would make the asymptote here probably negative 1 and positive 1. Negative 1 for this guy, positive 1 for this. That's just the roots of these two factors. Let's factor this guy here. I'm going to factor both top and bottom. 2x plus 3 and x minus 3. If you can't factor that fast, we can work through some together in class, but I'm just going to give you the fact. Oh, this is x plus 2. All right, I'm going to give you the factor forms in right here for you. So this looks like it probably has an asymptote at 3, and probably, I'm emphasizing the word probably on both of these, has an asymptote at x equals negative 2. But there is a chance that one of those won't be an asymptote, and if you look in here, you might be able to see why already before we get to it. So I'm going to write the domain a couple different ways, right? I'm going to write it in set notation. So I'm going to come up here and in set notation, let's define x. We've got x bar, and we're just going to say x can't be 1. Does not equal 1. Let's write it in interval notation as well. So from negative infinity to negative 1, union negative 1 to infinity. Ooh, you know what? That should be positive 1. Let me make these positive 1. We're talking about that. I think I was getting ahead of myself here. And this guy right here x bar, x in this case can't equal -1. Totally true no matter what, right? So we've got from negative infinity up to -1, union, -1 infinity, right? And then down here, we've got this. We've got from, oh, there's two of them here. So I'm going to give myself a little more room. I'm going to x bar this, right? And then I'm going to say x does not equal this one, -1, and x does not equal +1. Let's go ahead and end that. We're going to say that the same way here. We're going to say, hey, from negative infinity, I think I'd bump into -1 first, so I'm going to say up to -1 from left to right. Union, -1 to 1, right? Union, 1 to infinity. So that includes everything from -1 up to this first asymptote, everything in between those two asymptotes, and then everything from this asymptote all the way up to infinity. All right, so we're going to come here, and we're going to say these guys, so let's give myself some room. I'm going to say x bar, and this time my x cannot be, well, 3. And I should have probably done it in a different order. X cannot be -2, because I'm going to have to come down here, and I'm going to have to do that in reverse order here. So in set notation, I've got from negative infinity all the way to -2, which we're not allowed to be. Union, and then everything in between -2 and 3. Union, and then everything from 3 to infinity. All right. So I'm going to draw really quick sketches of this. All right, really quick sketches. So at 1, oh, in this case, it is at 1. All right. My graph does something that looks like this, and then something that looks like this. We'll talk about those graphs later, but you can see how we've got an asymptote, and I should probably go over the line right there to show that it goes right there. All right. This guy does the same thing, but he does it at -1. So at -1, this guy right here, he actually, there's something interesting that happens here. And when we start talking slant asymptotes, we will mention what happens here. The graph looks like that. It looks almost as if I drew a line down here, you could kind of see the line would fit across that. But we'll talk about this soon. All right. And this guy, if I draw this, something happens at -1. I'll put an asymptote there. Something happens at +1, right? And you're going to see a graph like this that hugs that asymptote. On this side, there's a graph that hugs that asymptote. And then we're going to get something weird in the middle. It comes down and goes back up. And so it looks like these are the only two breaks in the graph. And the final guy, which we're going to talk about soon, I graphed this on a calculator, but I kind of know how to graph it, but, well, forget the kind of. I know how to graph it. But this is going to tell us something we're going to discuss later. There is an asymptote at -2. This graph goes from here to here, all right? And I'll bring this up again later. And then at 3, you see a hole in the graph. All right, let's get the other side of it. And I'm gonna bring this up later. I think I'm just a little bit into this movie. We got 8 minutes in, all right? And I'm going to show you the graphs of these. All right. So I'm actually going to give you this information. And while I give you this information, I'm going to, we're going to talk about it pretty soon. This is that final graph. All right. This was the final graph on the other side. And the final graph on the other side, which we factored already, so I'm gonna factor it again on the other side. All right. I'm going to factor this into, what did we say? We have, what, 2x plus 3 and x minus 3. And this guy right here was x minus 3 and x plus 2. And you can test things really easy right there. If you plug this graph in to your graphing calculator, which I have, right? And if we need to do this, you can actually, so let me show you. I've actually plugged all of them into this graphing calculator, which is right here. And I'm going to go ahead and I'm going to delete some of these. I'm going to delete this guy. I don't need it anymore, so I'm clearing that out. I'm clearing this out. I'm clearing this out. And I'm going to go ahead and put the factored form in here. So whenever you do at the top, I'm going to do 2 sets of parentheses like this. And then I'm going to put that first factor for that one, which is 2x plus 3 end parentheses. The next factor, which was x minus 3, end parentheses, end parentheses. So now I've got the entire top, the entire numerator. I do divide, and I set 2 sets of parentheses in. That's to include the entire denominator. And I go x minus 3, end parentheses, begin parentheses, x plus 2, end parentheses, and then I've got that in there. And if you go to your table set, you can set your independent on ask, and you can plug stuff in. So if I plugged in negative 1.9, it would give me my output. It says negative 8, but if you go over here, it still says negative 8. All right. It doesn't really give you, oh, because it's negative 8. That's perfect. All right. And if I put in negative 1.99, it'll tell you 98. So you can plug in and get these answers. But I'm going to let you see what happens really close to this asymptote. Remember, this one would be an asymptote at x equals negative 2, and this one would have a root of 3. And as we approach negative 2, all right, from the right side, it shoots down. I mean, it gets huge, which is what creates that asymptote. All right. So as I approach negative 2 from the right side, it shoots down. That's what this is saying, right? And as I approach negative 2 from the left-hand side, it shoots up. As I approach negative 2 from the left-hand side, it shoots up. I'll let you get these numbers down, right? So what this tells us is that vertical asymptote is true, right? So at negative 2, there's a vertical asymptote. When we get to 3, look what happens here, right? As I approach 3 from the right side, that means I'm bigger than 3, right? I'm bigger than 3 and I'm coming from the left. I'm bigger than 3 and I'm coming from the right. There's really not much of a change. And even on the left side of it, as I approach it, there's really minute changes. So what this is it shows that there's a conclusion. I'm going to autofocus just in case. And we're going to try to finish up here in the next 2 or 3 minutes so you can have that first page done like I asked you. It shows that this factor, right, this function right here, and remember we've got it factored up here, this function has a vertical asymptote at negative 2, shown by no matter which side I approach it from. I got these huge numbers. But it doesn't have a vertical asymptote at x equals 3. So something has to be happening at x equals 3, right? Something has to be happening at this factor, which creates our root at x equals 3. And if you notice, the same factor, when it's in factored form, is in the numerator and the denominator. So technically, and I'll go ahead and put an x through this, you can cross these out. All right? And when you cross those out, it kind of negates the effect that this denominator of x minus 3, that factor, would normally create, that asymptote that we see. So it really graphs as if they didn't exist, with one exception. And I'm going to show you that exception, right? It graphs like 2x plus 3 over x minus 2, but it still has a hole. And if you graphed it, that's the graph we put on the other side. There's a hole there. I want to show it to you. Your calculator probably even shows that. So if we look on here, let's look at it. There's our graph. Somewhere around here at 3, right? That's what we were saying. Somewhere at 3, there's a hole. So let's zoom in. We're going to go to our window. And let's go from, let's make from negative 2 to 4. That would put it right in the middle of the graph. Let's go ahead and do that here too. It happened let's go from 0 to 4 and see if we can see it in there. So here we go. Somewhere we can't see it there. I'm going to have to zoom in a little. So let's change my window a little bit more. So I'm going to go to my window. And it happens at 3. So let's go from 2 to 4 and see if we can see it there. Here comes 3 right here. And it popped a hole in it. I don't know if you can see it right there, but there's the hole. It's so small, and as you zoom in, it's really hard to see. And honestly, it's just due to the pixels that you can see it. But we represent holes in the graph when there is a shared factor in the numerator and denominator by putting a 0 there. And I am going to practice this with you guys so much you're going to get it down. But this is the first page. That should give us 2 days to not only finish, but to get really far through our work. So thanks for working hard and doing this. 15 minutes. You'll find out that those first 8 questions on your homework are really quick. So I don't think I've given you a ton of homework, and I look forward. I hope you guys enjoyed a long weekend. Assuming this is the year that I did this video, and I'm not showing it again in the future years. I don't know if it's going to line up with a long weekend. But I look forward to seeing you again pretty soon. Enjoy your time off, guys.